All right, back here, Chris Bowman transmission, working on a Turbo 400. A little sick, so my voice will be a little bit in and out. Anyways, got a Turbo 400 here. Did come down, came from a race car, off-road car, and kind of was looking through a bunch of stuff on it and trying to figure out some things on it. But this thing, from what I've kind of understood, was built by a fairly reputable builder. Originally refreshed by someone else, and now it's here with me. So, tore it apart. From what I understand, probably doesn't have a ton of runs on it, ton of time on it, but I tore it apart to find the first things wrong. And the transmission was completely smoked. So, here was the issues right here, at least the results of some of the issues. This is the second gear clutch pack. And I don't know if you can see this or not, but it is completely, look at that, chunked out everywhere, chunks missing. That thing's been super hot. Oh yeah, that's a good view of it. See right there? This thing's been slipping and super hot. You can also see that if you look at this, that these steels have been reused. They've been sanded down and reused, which is not my favorite thing at all. There's some guys really like reusing steels. This one's got a ton of hot marks in it, and you can see that some of the hot marks were from previous, like right in here. That's previous because there's sand marks going through the hot marks. But quite a few hot marks in this from the original builder or from the refresh. I don't typically reuse steels unless for some reason I can't get to them, and then I resurface them. But 99% of the transmissions I do are going to have replacement steels in it. It's a little extra cost, but it's worth it in my opinion. So we come over here, we have our forward clutches right here. Forward clutches were in good shape. There was nothing really wrong here. But we come back to our direct clutches and same thing here. It's got smoked direct clutches, all pitted out, all from slipping, low pressure issues, things like that. So we come back over here and we're going to talk about this transmission for just a second. Grab a rag right now. Okay, so this transmission right here has some things with it. So this is a reed case. And with this reed case, you can have the option to do what we call center lube. And what happens is that the cooler flow out of your converter goes, all the fluid that goes into your converter goes out to the cooler, and then when it comes back from the cooler, it goes back into the case and it goes into the lube circuit. So all that cool fluid goes and lubricates all the bearings, bushings, thrust washers, planetaries, everything. Lubricates all that stuff up and then drops to the pan and gets sucked back up. When you have our Turbo 400s, typically were always front lube, which meant they come in here and they were channeled into the pump, and then from the pump they were distributed down the center of the shafts all the way to the back, and that's what lubricated everything. Reed was one of the ones that when they did their case, they came out with an option where you could actually, the fluid will come in here, some of it will go to the front, but the rest of it will go here and goes out to here and then gets looped over and comes over to here and goes into the center support. Now that's called a center lube setup. Now when you do a center lube setup, there's some things that you should do in there to mitigate some of the oil flow from the front lube, but it's not super critical. Things that I like to do, but the biggest thing is that when you run a center lube style setup in there, you need to use it all from the late 4L80Es, which is the 96 up 4L80Es all have a center lube setup. You have to run that gear chain complete, and if you don't run all those pieces, you are going to have starvation issues in the back, and that's what we had with this one. Now luckily this thing hadn't been run for very long, so it hadn't created tons of problems yet, but it was getting there. So let's take a look here. All right, so first things first, we have our 4L80E center support right here. Now this center support is special because that's just the same as every other Turbo 400, but the difference being is that we get over here and this is the center lube port right here. So there's a little seal in there, right there, and there's a little fitting that goes right in that case, and it directs the lube right into this center support. Now a normal Turbo 400 wouldn't have this because it's not center lube, it's front lube, but because this is the 4L80E setup, it does have it. Now the second thing that you have to look for when you're doing this center lube stuff is pretty important that your bushing be the correct bushing. And if we look in here, hopefully you can kind of see there's two holes in there, and you want the two holes. Now some of these are slotted together. You don't want that one. What you want is you want the two holes because it separates out the lube circuit from just dumping right out and into the lube circuit back here. Okay, so you want to make sure that it has the 2 holes and not the slot. This is correct. So this one's so far so good. Okay, the next thing that you want to do is you want to make sure that your center, your sun gear tube is the correct tube, and I'll show you why. Okay, so right here, this is a Turbo 400 sun gear tube. Only has a small groove in the center here, and if you look, these bushings right here are solid bushings that are in there. They have no oiling grooves or anything in them. Okay, so that's a typical 400 sun gear tube. This is the late 4L80E sun gear tube. And one of the things that you'll notice in anything that's the late 4L80E stuff is they pretty much always have this identification groove within the splines or the gears. So when you see this identification groove, you can pretty much know that this is going to be a late sun gear tube. Now this late sun gear tube, the difference with it is it has a wider groove area here, just to make sure that you can get the oil flow and stuff in there. So wider sun gear tube for the transfer of oil to, sorry, not for more flow, but for the transfer of the oil to that other hole in the bushing. So I'm not 100% sure if it's really super critical on the bushing or not. I've looked at it kind of both ways, and it doesn't make sense to me either way. On the Turbo 400s, the bushing is grooved the whole way. On the 4L80Es, the sun gear tube is machined for that groove. So I think it's kind of both the same thing, but that's okay. So we have them side by side, and if you notice, you can see that height difference right there. All right, so there is that height difference. So if we come right here, okay, this is what was in it that I pulled out of it, and if you notice, it actually started life as a Turbo 400, and it's been machined down to be the same as the 4L80E. So no biggie, no harm, no foul, everything's done. And if we look at it, the late 4L80E has these bushings with these oil channels in them. If you can kind of see that right in there, okay? You can kind of see the oil channels in there. So that's what we want to see, oil channels, okay? And the reason that's important is because of this. On a Turbo 400, the main shaft that's right here is hollow. So it's drilled through, it's got like a 3/8 hole going the entire length of it. Because on the front lube, all the lube goes right in the center of that, goes down this shaft, and then lubricates everything along its way and pushes all the lube around. Has some lube holes in here. So here's where I think the biggest issue is with going to the center lube. I don't feel like center lube on its own is a very good modification for these. I don't think it's necessary. Debates either way. I just don't see a lot of 400 lube failures if everything inside is set up right. Now that's the key, set up right. If you don't set everything up right in here, and you don't maintain all of your end plays, and not just your rear and front end play, but also your gear train end plays, you're not going to have proper lubrication, because you're going to be leaving open holes where lube can just fall right out and not travel down where it's supposed to and go back to the pan. So the whole thing has to, as a whole, be done correctly. And a lot of these just get slapped together, and it's not right. And it's the way builders have been doing it for a million years, because they don't understand better. And those are some of the little things that I do differently. Okay, but this is a solid shaft. So this is where, back to the center lube. I think the advantage to the center lube is that you can run the solid shaft here, which is arguably stronger. Debates either way as well. But the solid billet main shaft is kind of accepted to be the stronger shaft. Not that they don't break, it's a stronger version of it. Okay, now this thing, the sun gear tube does sit across this, which is this machine guy right here. And the reason it has to have that oiling grooves is because this is completely solid, so there's nothing that oils inside here. So the oil that goes from the center support, goes right into this hole, and then is pushed either way. Now, those little oiling grooves allow the oil to come out this way just a little bit, but the oiling grooves allow it to come out the other way. But what you'll notice is that, how does that oil get out of there? On the bottom side, well, here's the way it is. Okay, this sun gear is not the correct sun gear. This sun gear should have notches on it and should have oiling holes here. So even though this kind of works, it doesn't really work. So what happens is the sun gear tube right here goes down in there, and we're getting some oil out into the planetaries right here because there is an oil channel, but what we're not getting is the oil channeling to the back, which is what we like to see as well too. This ring gear is not the correct ring gear for center lube. You need to use the 4L80E ring gear, and the reason for that is this. Okay, I don't have a 4L80E ring gear sitting ready to rock, so here we go. This is the forward hub. This spline's on right here, okay? But what I want to show you, what matters is, see these 4 notches? On the ring gear hub from a 480E, you will have those exact 4 notches, which allows the oil to go through this and come out the other side, all right, and oil the things behind it. You want to have those because otherwise you will not transfer oil back. So this one right now, we have a bushing that sits in the tail housing right here, and this goes right into here. Okay? There was no oil getting to the back in that bushing because there was nothing channeling oil from this into this. All right? And this bushing has some wear on it just for the little bit it's been in there probably. But there was no pressurized oil getting back here or to this bearing right here. So we were already starving this for oil. Also, the bushing in the back of the case is what this shaft rides on. The bushing sits back in here, inside there. That bushing in the case relies on the pressurized oil from here to come out here and oil it. But what you'll notice is this is a 4L80E tail housing, or tail shaft, and it has no oil holes. If we look at the corresponding Turbo 400, we will notice that it has an oil hole right here. So the back bushing in here was not getting pressurized oil as well, which is a problem because we're going to have issues there. All that stuff needs to have pressurized oil. So in this rear lube setup, we have 2 failures. 3 failures actually. So 1, we have the incorrect ring gear, or 4 failures I guess. 2, we have the incorrect output shaft. Now we could remedy this by just drilling a hole in this. It is hardened, so you need to use something good like a carbide end mill or something and bore a hole through, and we can make it look like this. That's repairable. Okay. This guy right here is the next problem, okay? See this bearing right here? This bearing goes on this main shaft right here. Now, even if we had those 4 holes that were like this right here, okay? If we had these 4 holes here in this, and we used this bearing would basically block off those oiling holes. And if you look, when I drop this off, this bearing blocks off the oiling holes. So if you don't use a Turbo 4 or 4L80E style bearing, you will have no oil. Now the 4L80E bearing has 3 big notches out of this bearing, and since we have 3 on 4, you can never close off anything. So if there was 3 notches in here, no matter what, you would always have some open channels for lube. So 1, wrong bearing. 2, wrong ring gear. 3, wrong sun gear. 4, wrong output shaft. Okay, all those things are causing oiling issues in the back there. So that's some of the issues I found. Next issues I found. Forward drum. Now this is a fat shaft forward drum. It has a big spline here that they press in. So they've taken a stock drum, they've bored it out, they've custom made an input shaft that has a larger spline on where it goes into the drum so that we have less likely to spin the drum out right here. High horsepower stuff, this ends up spinning out here, but usually it has to be pretty big power, like over 1,000 horsepower typically is what I've seen, where it becomes necessary. But here's the thing is, I don't know if you can see this. This drum has got a step cut machined into it now, and you'll notice there's just a little bitty thin ridge outside here that's not very wide for surface area. Here's where the problem lies. The bearing that they were using there is a bearing from the rear gear train of the Turbo 400 here. And it's not an uncommon thing that they've done, although this one wasn't done properly. So they did bore that loose, but here's the rub, okay? That counter bore should center this bearing, and it does not. So this bearing's just floating around in here in space, it's got no home. Okay? That's okay though, because you only want one side to be piloted. Okay? Well, this guy goes in right here. Okay, and if we notice, this wobbles all around too, so it's not piloted. And if I show you right here, you're going to see that this race right here doesn't fit here either. So they've kind of screwed up. They've used a bearing here, which is okay. They've used a bearing here, which is okay, but they didn't machine this properly. So this thing's floating around, got no home. Eventually it finds its home and spins there, but reality is you want this thing to be true the whole time and not have to constantly find its own home. So there's nothing that keeps that centered right, and that's going to be a problem, because if this clutch pack engages with it being off slightly, it's going to cause it to wobble around and do weird stuff and potentially cause some vibrations. So I'm not exactly sure how I'm going to fix this problem yet. I will come up with it, but here's the thing where I was kind of trying to point out. Because they've machined so much of this away in this step, they've only left this little bitty razor edge right here that actually supports this bearing. Well, that's no good. You don't want that little bitty razor edge supporting that bearing. Ideally, you want a big flat surface that's exactly as wide as the rollers on the bearing, and that's not happening. All right, these rollers are pretty wide. You should have this entire surface here that's rubbing on where this bearing is. Otherwise, that knife edge sitting in the center there is going to cause some fatigue and uneven pressure on that bearing and the bearing race, and we don't want that. So this one's probably not as critical being the forward drum, because it's only going to spin when it's in reverse free, and that's why I don't normally use a bearing here much, because it's only this bushing or bearing only is effective when you're in reverse. That's it. Because in forward gears it's on all the time, and this drum and this hub are always locked down. The other thing that I don't like that they did is that they did machine this back for a bearing, so this looks like an early billet style hub, but they just took that same bearing that had that pilot on it, and they just took a grinder really quickly and ground it down. It doesn't really hurt anything, it's fine, but see how this bearing is tighter on there, but even that's pretty loose. See it? And that's what supports that, and then this goes against the direct drum. This one works. It's okay. It's not my favorite either. I'll probably replace this drum with one that's not been overly machined, especially for this build. It's just not worth the risk. I don't know what I'm going to do here, because this is a custom drum. I may end up trying to push or build a spacer that goes up in here to support some of this right here, so that maybe it will work out a little bit better, but I don't know. I got to do something here. Okay, so that's this issue right here. Next thing is, all right, so these guys decided to cut grooves in the bearing, the drum. Here's the problem with this, okay? They cut the grooves into both sides of each planetary. I didn't mean drum. Each planetary, and this bearing sits here and goes against there. Now they cut a groove in here. Normally this is flat and uses a thrust washer. These are the 4 tangs where the thrust washer would go. They cut a groove into here, and they cut a groove into here, but they cut so shallow of a groove that this thing just doesn't want to stay in here. Like, it won't stay. Right? It just wants to push out. Well, that's a problem, because the only thing that keeps this bearing centered is those grooves. So unless you have this thing really preloaded tight, it's not going to want to stay in those grooves. So if you have 10 thousandths of clearance, this bearing is going to want to flip out and move. Okay? It's the same thing on this side. They only took a little bit out of both sides, and it doesn't stay in there. The other thing that's a problem is when they lathe cut this, they didn't do a good job. And what you'll actually notice, I'll grab just a random piece of material here, is that as we slide this up, okay, that one works. See how when I slide it all the way over, oh no, there it goes. It catches right there, and then it bumps over. These pins, like this one right here, this one is really proud. See that pin? It should slide really easily right across, but it doesn't. This pin is proud by a few thousandths of an inch, and it won't let it go. Same here. Okay, that one's a little bit better. But the problem with that is that if you don't pay attention to that, this bearing right here is only being supported on these. Oops, these bearings are only be supported on these 4 outside corners, which is going to warp and bend that bearing, and it's going to shorten its life. It's going to break, damage, rip apart. So you have to pay attention to that. Now on the flip side, when I machine these, okay, we machine a big groove in these. See, if you look, it doesn't move around. I only machine the one side, and I machine a deeper groove in it so that it really makes sure I lock that bearing down. And we also make sure that these bearings, if you noticed the way that these are machined, we spend a lot of time making sure that these are right. Sometimes I do have to go back in there and dress them up slightly with a little bit of a disc, just to lower them slightly or take the edge off them, because these are harder material and a little bit harder to cut. But you have to pay attention to that. So that's another problem right there. There's no way this bearing is going to last for very long in this thing. And you can actually see, if you look at the evidence of this bearing, there's some weird things going on with it and weird wear patterns on the bearing. And I know it's just because of that. You can see like some weird wear marks here. It should be concentric wear marks even all the way around, and it's not. So that's an issue. All right, next issue is this has got an early TCI valve body from what I can see, and it should be an engine braking valve body, and the way they do their engine braking is a little bit weird, and I don't like it, but it is the way it is. But here's one thing that I noticed, and I don't think this is right. I'm going to have to get with TCI and ask them, because they no longer have the instructions for this particular setup on their pages. But if you look here, this is the accumulator that goes inside the low reverse piston here. This accumulator does not have any seals on it. That's the way someone put it together. Now, a lot of aftermarket valve bodies will have you remove the seals from this, but when they do, there's a port down in here that they will plug, and it comes all the way over to here. This plug is free. It's not plugged. Or this port is free. It's not plugged. Normally, if you see these off of here, that port has to be plugged, or on the valve body plate right here, that port will be capped off here. Well, it's not. This hole right here lines right up with that. So this actually goes into the valve body. And if we flip this guy over and look at it, okay, right, there's the ports that we had right here, is this little guy right there. And if you notice, that little guy is connected in this channel all the way through where it's been machined out. And so that little port is connected all the way. So now we've got fluid coming all the way through there. Now maybe that's the way they set it up in order to have release oil, more release oil pressure, I guess, on the servo instead of just instead of somewhere else. But normally this right here, this hole is the release oil pressure for the servo. So I don't know what they got going on here. There's some weirdness there. I would have thought they would have plugged that. In fact, the TCIs, the earlier TCIs, you plug that. You don't leave that open if you take the rings off of this. So maybe this is the way it's designed. I don't like it. I don't like it when you have to do a lot of case modifications to a case to do the valve body, because it makes it hard if you have to change it later to a different style valve body or whatever the customer wants. I like it when they retain most of the mods in the valve body itself. And so that's what I'm a big fan of. Not a big fan of modifying the case to do it. So luckily this one hasn't been modified. We might put a different stuff in it or put different things in it. But this is a very small amount of things that I was looking at that this thing has problems with. The pump itself has problems. It's got a worn pump inside of it, which I'll have to remedy that. It's definitely loose, which causes some low oil pressure. It's a few thousandths too much clearance because it was just an old used oil pump in there. Nothing spectacular, nothing great, and it looks like a factory OE style pump gear set, so I don't think it was ever changed. And I don't know who did that. But these are just some of the things, man. You'll notice that when you get a transmission from me, I'm not going to go into a lot of the mods that I do to them because they're kind of proprietary to my little things that I've learned over the years. I am big on making sure that whatever parts we use work well together. And the majority of transmissions that come across my bench that have been through several builders and usually don't go to another builder after they come to me is because I do these little things. I go through and I make sure that every piece in this transmission is the way it needs to be, where it needs to be, and how it needs to be, so that they're all going to function together. That's it. You can buy all the $1 million parts for this transmission you want, and if you don't build it to make sure they last together, it'll never last. And it'll always be somebody's problem, or the parts, or the builder, or the car, or the cooler, or the whatever, right, that we're going to blame. But the reality is, most of these transmissions I tear down, this is the problem. Just lack of knowledge, mismatched parts, even from, man, I don't like to name names, and I don't want to do that. I won't talk shit about other people's transmissions, like, and specifically name them, bring them out, but I have done a lot of work that have come from really high dollar builders that have been crap, total crap. And it's amazing how much these guys get paid and how little I charge to go through and fix these right. This transmission will be so much better when I get done with it. Just some little things that are going to be done are going to make it so much better. It's going to take a little bit of work. There's some labor involved in making sure all this is right. Most companies don't want to spend the time to do these. On a race transmission like this, it's not uncommon for it to take me, 12 to 16 hours of assembly time on this, even with new parts. And it's just because I spend a lot of time making sure all this stuff is right, correct, and ready to rock. And you can't always catch it all, but I do my best. Hopefully my customer is going to go for replacing this valve body with something better. This valve body is no longer produced. So we'll see. A lot of times when you call up for technical support at TCI, sometimes you have problems finding somebody to even talk to, that knows what you're dealing with, but maybe they'll be good this time. Sometimes they are, sometimes they aren't, but I need to find information on this particular, valve body for installation purposes. I don't like the way that they do the second gear band apply, which is right here. if you look, this port is normally not drilled through, and they've drilled through right here into this casting, and they've brought it back over into here, which also goes over to the second gear oil. So they're transferring oil through this port, and they're catching it over here and bringing it in here. So that's kind of an issue right there. It's not really an issue. I just don't like the way it's done, because it eliminates the usage of the check ball right here. Normally in a stock transmission, this check ball would be utilized for the application of the band. And one of the things that I like to do is to utilize that check ball and drill the hole a little bit bigger, just to slightly slow the apply of the band just the littlest bit, so that we make sure that the sprag engages and the band applies, kind of in that order. So we go sprag band, right, real quickly. Some builders like the band to apply first. What I've found is if the band apply first without orificing it down, that the problem that you can have is that you are, oh, the band's over here, is that you will burn this band up right here, because it'll engage too fast, and it'll actually start slowing the drum down before the sprag catches it, and that can cause a little bit of burn. The other thing that I don't like about this without using it is that when it releases, we want it to release really fast when we go to second or first or third, and it has to release back through the same hole that it applied through. Now, oh, sorry about that. If we use a check ball, the check ball is meant so that on apply it orifices it down, on release it's a big huge open hole. That's what check balls do. At least these the check balls that aren't in the bathtub. This bathtub check ball does something different. It directs flow from one side to the other, so that you can power this reverse band up through either low or from reverse with two different fluid applies, and still apply the same clutch or same band. But these rest of these check balls, except for this one, when you do one of these, most of the time you have to have two check balls a minimum on a 400, which is these two. If you don't have those, it's going to have problems. You can eliminate the other ones if you want to. I choose not to, because I like to orifice my clutch apply down just slightly. But these check balls like this one right here, 1, 2, 3, 4, these check balls right here, they allow the apply to be controlled and the release to be fast. That's what the check balls do. So anyways, it's just some of the different things here. Hopefully you guys didn't get too bored watching this, and hopefully it works out pretty good. But there you go.